Hello and welcome back to Math 1500 Applied Business Mathematics, Connecticut State Community College. In this video, we're going to look at applications of systems of linear equations. And if you've been watching the videos, you'll recall that 2 videos ago we talked about solving systems of equations algebraically. And in our previous video, we looked at solving systems using matrices. In this video, we're going to look at the application. Obviously, I've got a word problem here and got 4 quick word problems. I hope they'll be quick word problems, application problems, and we're going to create a system of equations from the problem given. We're going to solve that system of equations. In some of the cases, I'll solve the system by algebraically, and some using matrices, and we'll explore the better options there. So first of all, when I have an example like this, blending, the Arctic Juice Company makes 3 juice blends. Make a pine orange blend using 2 quarts of pineapple juice, 2 quarts of orange juice per gallon. Pine kiwi using 3 quarts of pineapple juice and 1 quart of kiwi juice per gallon. And orange kiwi using 3 quarts of orange juice and 1 quart of kiwi juice per gallon. Each day the company has 800 quarts of pineapple juice available, 650 quarts of orange juice, and 350 quarts of kiwi juice available. How many gallons of each blend should it make each day if it wants to use up all of the supplies? So the first thing I need to do is I need to figure out what are the equations I'm working with and what are the variables. So first of all, I'm going to say that we've got pine orange, and I'm going to abbreviate that with PO for pine orange. We've got pine kiwi, so I'm going to call that PK for pine kiwi. And then we have orange kiwi blend, which I'm going to abbreviate with OK. Now you'll notice the question at the end, how many gallons of each blend should it make? So I want to know how many gallons of the pine orange, how many gallons of the pine kiwi, and how many gallons of the orange kiwi. So I'm going to use those variables, X, Y, and Z, to represent those blends that we're going to make. Also notice that we're told how much pineapple juice, orange juice, or kiwi juice is used in each blend, and we're also given a total of how many quarts of each juice are available. So there's a pineapple juice, an orange juice, and a kiwi juice that's going to go into those blends. So those are the equations I'm going to set up. I'm not going to do anything with the POK, but those are the juices available. So pine orange uses 2 quarts of pineapple juice. So I'm going to use 2 quarts of pineapple juice and 2 quarts of orange juice for each gallon of the pine orange. The pine kiwi is going to use 3 quarts of the pineapple juice, and it's going to use 1 quart of the kiwi juice. So notice the pineapple juice, 2 quarts goes into the pine orange blend and 3 quarts goes into the pine kiwi blend. Then there's the orange kiwi, uses 3 quarts of orange juice and 1 quart of kiwi juice. So that's for the orange kiwi. For Z, we're going to use 1 quart of orange juice, and we're going to use, that's 3 quarts. I lost my place. For the orange kiwi, we use 3 quarts of orange juice, and we use 1 quart of kiwi juice. Each day, the company is going to wants to use up all 800 quarts of the pineapple juice, all 650 quarts of the orange juice, and all 350 quarts of the kiwi juice that's available. And now I need to solve that system. If I'm going to solve this system, quite honestly, I choose to solve the system algebraically, because I'm going to start with the fact that we know that 2x plus 3y equals 800, and we know that 2x plus 3z equals 650. So I'm using the top 2 equations. And I'm simply going to subtract the bottom equation from the top. So 2x minus 2x, these will cancel. 3y minus nothing. Then we have the minus 3z. And then 800 minus 650 is 150. Now the other thing I would do here is I would multiply this entire equation by 1/3. So 1/3 of 3y is 1y, 1/3 of 3z is 1z, and 1/3 of 150 is 50. So my resultant equation there is y minus z equals 50. And then notice that my third equation was y plus z equals 350. So that's all set up just to combine those two equations. Y plus y is 2y. A negative z and a positive z are going to cancel out. The 50 plus 350 is 400. And now when I divide both sides of this equation by the 2, y equals 200. And now I can work backward. Okay, we know, take this equation here, that y plus z equals 350. So 200 plus z equals 350. So then when we subtract the 200, we know that z equals 150. I can also use the fact that y equals 200. I'm going to use that in the top equation, where we know that 2x plus 3y, which is 200, equals 800. So 2x plus 600 equals 800. When we subtract 600 from both sides, 2x equals 200, divide by the 2, x equals 100. Y equals 200, z equals 150. So the three blends, the pineapple orange, they should make, x was 100, they should make 100 gallons of that. Y is 200, and z is, where did it go, 150. And so there's my blends and how many I should make of each. The trick here really is just getting these set up. Now if you wanted to use matrices, and I go to my calculator, second matrix, I'm going to edit my matrix A. Matrix A is a 3 by 4 matrix because there would be 3 rows and 4 columns. The thing you have to remember here is that we have the first equation is 2x, 3y, and 0z equals the 800. So you got to remember to get the zeros in the right place. My second equation is 2x plus 0z plus, 0y plus 3z equals 650, and then 0x plus 1y plus 1z equals 350. Okay. I'm going to quit. Second matrix, math. I want to use that reduced row echelon form, option B. And then we got to use matrix A. Enter. And you'll see the solution of 100, 200, and 150 for each blend. Okay. So I got a couple more examples. This one, aircraft purchases, Airbus and Boeing. I will tell you one of the things in this equation or this problem that gets me sometimes a little flustered is we're using the names of the airline or the airplanes. A new airline has recently purchased a fleet of Airbus A330-300s. Use different colors here. Boeing 767-300ERs. And then another color, let's use orange, the Boeing Dreamliner 787-9. Okay, so I've got to label these carefully, and then as I go through the problem, make sure I keep things straight. So we've got the Airbus, that one's easy, it's just Airbus. We've got the Boeing 767, and we have the Boeing Dreamliner 787. And again, I'm going to use X, Y, and Z for each of those. So now what's the information? The new airline has recently purchased a fleet of these airliners to meet a demand for 5,400 seats. So I'm going to call that seats, or passengers is going to be an equation because we know that that's going to be the case. Now the Airbus, 330 passengers per plane, where X is the number of planes, at a cost of $250 million per plane. So the second equation is cost. Okay. The 767s, so that's Y, will seat 270 passengers, and they cost $200 million each. The 787, that's my Z, they seat 240 passengers and cost $250 million each. The total cost of the fleet, now we know we want 5,400 passengers or seats, so this top equation's got to equal 5,400. The second equation, the cost, we said that this has a cost of $47.50 or $4,750 million. That's 4.7 billion. We're still working in millions of dollars, so 47.50. Okay. We're also told that the fleet had twice as many of the 787s as it does the 767s. Now here's what I do. The 767s are Y, the 787s are Z. It's very easy to get this backward. We have twice as many of the Z as we do of the Ys. For every one Y, there are two Zs. For every one 767, there are two 787s. To set this equal, I have to multiply the Y by 2 to get that to equal Z. So that gives me 2Y equals Z. To put that back into the system, 2Y minus Z would equal 0, because I need it set up where I have an X column, a Y column, a Z column, and a solution column. These numbers, you'll notice, are fairly large. I could reduce them, I could make them smaller. This is a case where I'm not sure that it makes sense to try to solve the system algebraically, given we have our matrix method. So I'm going to go running right to my calculator, second matrix, and I'm going to edit my matrix A, which is still a 3x4 matrix, with 330x, 270y, 240z, 5,400, 250x, plus 200y, plus 250z equals 4750. Now this third line, you got to be careful, it's 0x plus 2y minus 1z equals 0. So I've got my matrix entered correctly, second quit. And as I've mentioned to you before, since the last thing we did in the calculator was the reduce row echelon form on matrix A, all I have to do now is press enter again, and we'll see that x equals 5, y equals 5, and z equals 10. So that means that we want 5 of the Airbus, 5 of the 767, and 10 of the 787 Dreamliners. This may happen at a particular school. I'm not sure how they do the scheduling at Connecticut State Community College. But at Urban Community College, they're planning to offer courses in finite math. So again, I'm going to list the courses. Finite math, applied calculus, I'm going to abbreviate, applied calculus, and computer methods. Finite math I'm going to call X, applied calculus I'm going to call Y, computer methods I'm going to call Z. There's our pattern. Okay. Now let's look at the information that we have. Each section of finite math has 40 students, and it earns the college $40,000 in revenue. So we also know how many students, I didn't read the whole equation or the whole problem for you, but we do know they want to accommodate a total of 210 students, revenues, and we also have a total number of sections. Okay? So I'm going to need an equation for the number of students, revenue, and sections. Finite math, X, has 40 students, and it earns the college $40,000 in revenue. I'm not going to work in dollars, I'm going to work in thousands of dollars. So $40,000 I'm going to call 40. Each section of applied calculus also has 40 students and earns the college $60,000 in revenue. Each section of computer methods has 10 students and earns the college $20,000 in revenue. And we also know that the college wishes to offer a total of 6 sections, so X plus Y plus Z equals 6. And again, as I said before, we want to accommodate 210 students, and we want to ensure $260,000 in revenue. Okay. Now, on the one hand, given the numbers, I might look at these numbers and say these are fairly large numbers. So I'm going to go to my calculator, second matrix. I'm sorry, that's not what I want to do. I want to go to second matrix. I want to edit my matrix A again, still a 3 by 4. We have 40x plus 40y plus 10z equals 210. We have 40x plus 60y plus 20z equals 260, and we have 1x plus 1y plus 1z equals 6. So I quit. Press enter to solve that, and we see our solution of 3 sections of finite math, 2 sections of applied calculus, and 1 section of the computer methods. Goes fairly quick with the calculator, but one thing I will show you, I'm going to change colors just to highlight a difference here. Notice 40x, 40y, 10z, 210, they're all divisible by 10. I can change that equation to 4x plus 4y plus 1z equals 21. I divided the entire equation by 10. If I look at the second equation, 40x, 60y, 20z, 260. Not only are each of those numbers divisible by 10, they're all divisible by 20. So the first equation, I divided by 10 or multiplied by 1/10. The second equation, I'm going to divide by 20 or multiply by 1/20. So I have 2x plus 3y plus 1z equals 13. The bottom equation, I could just leave it, x plus y plus z equals 6. I can take my top 2 equations, 4x plus 4y plus z equals 21, 2x plus 3y plus z equals 13, and I could subtract the bottom equation from the top. 4x minus 2x is 2x, 4y minus 3y is 1y, z minus z, those will cancel, and then 21 minus 13 is 8. If I take my bottom 2 equations, 2x plus 3y plus z equals 13, and x plus y plus z equals 6, and I subtract again the bottom equation from the top, 2x minus 1x is x, 3y minus y is 2y, these will cancel, equals 7. So now I have these 2 equations here. I'm going to take the 2x plus y equals 8, and we have x plus 2y equals 7. Let's multiply one of the equations by -2. I guess let's multiply the bottom equation by -2. So we'll have 2x plus y equals 8. Negative 2x minus 4y equals a negative 14. The 2x's cancel. Y minus 4y is a negative 3y. 8 minus 14 is negative 6. Y equals 2. And then now I can work backward. Y equals 2. So let's go back to this equation. 2x plus y equals 8, where y is 2. Subtract 2, so 2x equals 6, so x would be 3. X is 3, y is 2. We also know that x plus y plus z, I'm going all the way back to this equation here, that the total number of sections was 6. 5 plus z equals 6, so z equals 1. So I'm not advocating that you should want to use algebra to solve the systems. Simply what I wanted to show you is that because the numbers are simpler, actually they're all divisible by either 10 or 20, I can actually make the problem easier to work with if I reduce the numbers. Okay. Personally, in that case, I probably would use the calculator matrix of equations if I have one close. If I don't have one close, I would do it algebraically. Finally, let's look at investing. An investor has $5,000 to invest in 3 different accounts. Go to low risk, medium risk, high risk. A lot of information. Notice at the bottom. Let's find that again. Whoa. Let's look at the bottom. How much money should be invested in each of the accounts? So we've got a low risk. Let's just name this column risk. We've got low risk, medium risk, and a high risk account. Again, let's call them X, Y, and Z to make the math a little bit easier. The investor has $5,000 to invest. So X, the amount of money invested in low risk, plus Y, the amount of money invested in the medium risk, plus Z, which is invested in the high risk, is a total of $5,000 invested. The low risk account is expected to pay 5.2% interest. Now, I'm going to take a little moment here and talk about, we're often told, and correctly told, 5.2% is 0.052. I can get tangled up in my decimals if I'm not careful. So I'm going to take a moment and say, what if we know that 0.052x equals 10? I could multiply both sides by 100. 5.2x equals 1,000 because I've multiplied that. Okay. What if we have something like 0.052x equals 0.08y? Again, I could multiply both sides by 100. 5.2x equals 8y. I guess what I really want you to see is that 5.2% as a decimal is 0.052. But if I have 8%, 0.08 on the other side, I can multiply both sides by 100 and use 5.2 or 8, and it's not going to make a difference mathematically. So I'm going to, instead of using all of the decimals, 5.2% return on the low risk. The medium risk investment is expected to pay 6.7%. So I'm going to get 5.2% on the X dollars, 6.7% on the Y dollars, and then the high yield or high risk is expected to earn 10.3%. Now I'm okay with my decimals here as long as I remember at the end we want to anticipate an 8% return on the investment. So don't miss, If I do 5.2 for 5.2% interest and 6.7 for 6.7% interest, I need to use 8 for the 8% interest. Because I have that movement of the decimal equally on both sides, I'm okay. The total investment was $5,000, so this is 8 times 5,000. And now again, you'll notice, due to her age, the investor is willing to invest twice as much money in the high risk as the low risk. So I'm going to come down to my scratch work down here. I've got low risk, I've got high risk. She's willing to put twice as much money in the high risk as in the low risk. So for every $1 in the low, there's 2 in the high. I need to multiply the low risk by 2 to equal the high risk. So 2x equals z. If I subtract z from both sides, 2x minus z equals 0. This is the catch that a lot of people miss, so be careful with that. 2x minus z equals 0. Given these numbers, I have no intention of doing this algebraically. Okay, I could if I had to. I have my calculator close. Second matrix, edit. Still have a 3x4 for all 4 of these examples. 1x plus 1y plus 1z is a total of $5,000. 5.2x, 6.7y, 10.3 z, and 8 times 5,000. And then we have 2x plus 0y minus 1z equals 0. So I can quit, press enter, and you'll notice that the x, the low risk, is $1,140.35. Y, the medium risk, is $1,578, and we'll round that to 95 cents. And then Z is $2,280.70. It does bother some people when it's not an even dollar amount. That's okay. It's money. It will work out that way often. And there's our solution. Okay. Now, something you could do to check this, first of all, is it true that there's twice as much money in the high risk as there is in the low risk? That is true. Okay. Now, there's 2 things I want to show you before I end this video, and you might decide that they're tedious. That's okay. What if you were arguing with me still that we should have not used 5.2, 6.7, 10.3, and 8, that instead what we should have done is used 0.052, 0.067, 0.103 for the 5.2%, 6.7%, and 10.3%. But that means you earned 0.08, 8%, 0.08 interest on the $5,000. Quit. You'll get the same result. Okay, mathematically it does not matter. All right. So there you go. There's 4 problems. I'm looking at an application of systems of equations into different types of word problems. I kind of think the money one might be the most applicable for me in a normal situation. The scheduling is something I might use. But I hope that this is helpful, and I hope to see you back for our next video. Thank you.